So hello everybody and welcome, and I'm really happy to give you a presentation about pollen analysis application for wheat and other small grain cereals. I want to start with an outline. At first we want to talk about the background, the reason for pollen analysis, some applications. Then we will talk about methods for pollen analysis, for pollen viability, lifetime and quantity. And then we will head over to the application in DH protocols. And finally, we will sum up the main points with the conclusion. Short, we want to talk about the background. So we know that the flowering period is the most sensitive period to plant stress. That means lines with stress resistance, they can be identified by pollen analysis. And if we are focusing on the hybrid breeding, then we know that the pollination is a key element. So we have to ensure that we have synchronous flowering and sufficient pollination. So in detail, we can optimize the female to male ratio by using the pollen analysis. And in the end, this leads to more hybrid seed production per area. The production of hybrid seeds is cost effective, so therefore using pollen analysis is really a key feature. So which challenges are with pollen analysis in cereals? So we know that the pollen quality, it varies between the anthers and the spikes, and this requires a robust sampling method. We also know that the pollen in general is short-lived, and therefore we need an efficient sampling and sample preparation protocol. And with wheat pollen, we have the problem that it bursts really fast if it's suspended in liquids, and this requires fast measurements. And I have a really nice video for you where you can see how the pollen is bursting in the buffer. And you can imagine if the pollen bursts in the buffer, you cannot measure it with other techniques or something like that. So basically, it's considered then as a dead cell. So going further to the techniques, which techniques are available, I think we can cluster it mainly for staining germination. These are techniques that are under the microscope performed, and our Amphasys 32 pollen analyzer. By comparing these two techniques, we have to consider, of course, the time and how long does it take to get the result. And with germination assays, for example, it takes up to 120 minutes that you can count and you can get the results. With our technology, it's possible to generate the data within 1 to 2 minutes. If we are focusing on the sampling size, then we can say that with germination and also staining, you have to do with around 100 cells. You cannot really count more because you have problems with overlapping, especially if you think about the germination, so the tubes are overlapping, so the distinguishing between viable and dead is really hard. And in contrast with our technology, you can easily quantify up to 10,000 cells. So that means you will get a better and a more statistically robust result. And if we are focusing on the user dependency, then we can say that the germination, the staining method, they are highly user dependent because you have to, if you're doing 8 hours of germination tests, it's hard work to do, and I cannot think about that everyone can perform the same results over 8 hours. So it's really a high user dependent, and with our technology, you have a low user dependency. You can measure in the morning and also in the evening, and you will always get the same results. It's the same, you can measure across the world and you will always get the same results. And I showed you the video before of bursting of wheat. So if you're focusing on the bursting, this is also the risk is very high in the staining and the germination methods. And with our techniques, because it goes really fast, it's way lower. But now the question is how you get a representative sample to measure. So what we did, we developed different methods how you can extract the pollen from the spike. And we want to start here with the first method. It's the anther picking method. Maybe you already know that it's used for emasculinization or for breeding if you are harvesting basically the mature anthers and you want to do the crossings. And basically what we did, we extracted the anthers short before elongation or pollen shed maturation, and then we put it in an Eppendorf tube, let the anthers pop up, then we rinsed the Eppendorf tube with our measurement buffer, and then we performed the measurements. This is a really cumbersome work to do, so we thought maybe we can change it a little bit. So we basically developed the ear stripping method. Basically, we were stripping off the spikelets from the rages, and then we put it in the falcon tube and let the pollen also, or the anthers, pop up. Then we rinsed the falcon tube with our measurement buffer, and then we performed the measurements. The third and the fourth method, they are actually quite similar. There was the so-called spike cutting method used. I will introduce you into that later on. And basically we cut off the spikes, then we performed the spike cutting method, and then we put it upside down in a paper funnel and also in a falcon tube. And let me just show you here the spike cutting method. It's really important that you are selecting the right stage, and we identified the right stage when a few anthers are out. And what you have to do, basically, you have to remove, for the sampling method, you have to remove the anthers because they can also have dead pollen in there that's got stuck somewhere. And then we perform the spike cutting by cutting off around 1/3 of the spikelet. And then we immediately put it in a paper funnel. This was attached to a filter, and in an Eppendorf tube, we collected the pollen. And the pollen shed, it goes quite fast. You can see this in this video here, how fast the anthers, it's a time lapse, how fast the anthers are extruded by the filament, and then the pollen shed starts. So basically you can perform a measurement after 10 minutes. Here I want to show you the results of the comparison of the different extraction methods. On the x-axis you see the 4 methods that we were using: the anther picking, falcon stripping, and the funnel method. And on the y-axis, you see the pollen viability. On top, you see the cultivars that we are using. We tested this in 4 different cultivars. And the results of this experiment were that the falcon cutting and the falcon stripping, they had lower viability over all cultivars. But you can also see that the anther picking method and the funnel method had higher viability. And what we can conclude from that, if you can harvest the plant, then we really prefer the funnel method because it has lower error bars compared to the anther picking method. But that's not always possible. If you want to use the plant material later on for crossings or whatever, then then you can also perform the anther picking method. But as I told you, if you can harvest it, then I would recommend the funnel method because you get an average across the whole spike. Another very important aspect in measuring is the pollen lifetime. And this includes, for example, if you want to prepare it in batch or something like that. So you have to know how long is your pollen stable or how long it keeps the viability. And therefore we performed a measurement over a time course of 100 minutes with a time interval with 10 minutes. So basically every 10 minutes we measured. And we collected the pollen with our developed funnel collection method. And what we can see that over all 4 cultivars, the drop in pollen viability goes quite fast. So after 1 hour in these three cultivars, they were losing more than 50% of pollen viability. So basically what we can say that you have to measure fast in order to get very accurate pollen viability measurements. So this leads now to the next slide here. We were thinking about how we can extend the pollen lifetime. So we performed one experiment where we applied 2 treatments. One was 22 degrees. This was at room temperature, and 4 degrees in the fridge, where we put the pollen in the fridge. We collected the pollen also with the funnel collection method. And what we can also see here, that the pollen viability, it drops very fast in both scenarios or in both conditions, under both conditions. But with the fridge method, so storing at 4 degrees, it goes slower. So it has some kind of a preserving effect, but in terms of measuring pollen viability, this is not really an option to store it for 1 hour or so and perform the measurement. So we recommend to measure immediately, so within 15 minutes, to get the initial pollen viability. Now I was talking about pollen viability. The other side and most important part of the coin is the pollen amount. And we thought, okay, how we can quantify the pollen amount. So we used the so-called spike bagging method by bagging the spikes before flowering. We basically inserted a spike in the bag, and then we let the pollen shed there until the flowering period was over. And then we collected the pollen. We create a suspension with our counting buffer, and then we performed the counting. And what we found out, that the big advantage of this method was it can quantify the pollen shed under field conditions. We don't have to harvest any plants, and it is a fast and also reliable technique. We also experienced some disadvantages regards to weather dependency. If it's raining, then it's not possible because the bags, they're getting wet. And the same issue we also experienced with condensation, especially if you have humid nights, then the bags, they're getting wet, and then the pollen can get clumpy, and then the counting cannot be performed. So then we thought about, okay, how we can put the spike bagging method in a more controlled environment. So we cut off the spikes and the stem, or at least the stem with the spike, and then we put it indoors, so basically in the lab. Then we inserted the spike in the bag, and we let the pollen shed indoors. So we had the advantage there that we can avoid these condensation issues. We are not weather dependent, and we also don't have to go to the field again to remove the bags and these kind of things. But you also experience some disadvantages regarding this does not represent fully the real conditions like they are occurring in the field. And also the plants, they have to be harvested. And as I told you at the beginning, with the anther picking method, that's not always possible to harvest the plants. So that's a drawback here on this method. Nonetheless, I want to show you the results of the spike bagging method indoors. So basically we were using 5 cultivars. You can see it on the x-axis, and the released pollen grains per spike on the y-axis. And we basically let the pollen shed indoor, and then we create the suspension in our counting buffer, and then we did the counting. And what we can see, that difference between the cultivars exists, and also within the cultivar we have a variation across the spikes. And what we can also say that, for example, cultivar 4 has around 3 times the amount of pollen of cultivar 1. Now we are focusing on the spike number, but what's also important is how much pollen you get per area. So we thought about how we can quantify the pollen amount per area, and therefore we developed so-called liquid pollen traps, and you can see the illustration on the right-hand side here. So basically they consist of a paper funnel, a filter that's important that no insects can fall in, and our counting buffer, our Amphasys counting buffer. And so basically the pollen grain falls in the funnel, it's guided through the filter in the counting buffer, and in the field it looked like this here. So basically the funnel was around the same level as the spike was. And we also experienced some advantage of this method. It's a convenient solution for monitoring the pollen shed. The pollen is also stable in our counting buffer, so basically it can be stored up to 4 weeks. And basically if you have a lot of work to do, so basically you can store it and do the analysis later on. And it's also fast and counting and operating. And what you can also do, you basically can quantify the pollen shed characteristic by putting every day or every single day a new, or you basically replacing the counting buffer, and every second day, and then you can count, and then you basically can determine the pollen shed curve. We also experience some disadvantages because if it's also wet outside, the paper funnel can get sticky or wet, and the pollen can stick to the wall. And therefore, we developed the method further. So basically, we were using a plastic cup where we filled the counting buffer, and we put a mesh on top and on the stick. And this method was used in corn. My dear colleague Federica will elaborate more on corn tomorrow at 3 p.m. And basically, we can, with these techniques, with this design, we can avoid this condition, and we had very good results with it. And maybe some of you already asked yourself, what about rain? Yeah, in the field rain occurs, of course. And therefore we checked what's the influence of rain in the pollen traps. So we performed a simulation, a rainfall simulation, where we suspended the pollen in a buffer. We added rainwater to that buffer by dilution. So you can see here the 11 rainfall scenarios. And what we can see that basically you can perform the counting over the whole range between 0 rainfall and 50 liters per rain, and basically the rainfall had no influence on the counting. So basically it's a very robust method. What you maybe should take care about, if you have a lot of rainfall and basically you got an overflow out of the pollen trap, then you should really avoid that, because you will lose basically pollen grains, and then it's not robust anymore. But just by diluting it, you can basically count it. It's not a problem. So basically, it's a very robust method for pollen collection. So now we are facing mainly about this part here, about the mature pollen, about pollen viability and the pollen amount. Let's focus more on the step that's a little bit before, because in this step you can also use our technology to determine the different developmental stages that you are using or that you need for DH protocols. And what we did this year, we created an overlay. So basically this is a scatter plot that you will get out of Amphasoft. And you can see the phase and the amplitude. And what we did, we measured pollen or microspores with different developmental stages. And we stacked these on top of each other. And basically we create that pathway. So if you have a lot of early nucleate cells, then you have a high phase and a low amplitude. And as the pollen development continues, you have a cell growth, and until late uninucleate stage, basically you have a reduce in phase and an increase in amplitude. And if it goes to binucleate stage, you have just an increase in phase. And if you get to the mature pollen, to the trinucleate stage, you basically have a higher phase and a higher amplitude. And to know this path, so basically you can determine how much uninucleate and how much late nucleate or binucleate or trinucleate stages you have. And we performed these tests on one spike here over several different spikelets right before or before flowering. It was at BBCH 51. And what we found that differences across the spikes exist. And you can see the same that I showed you at the beginning, that the most developed cells are in the center of the spike. You can see also here the biggest part of trinucleate. And if you go to the top, at the bottom, you find the most uninucleate. And what you can do, basically, you can sample in these areas in order to increase uninucleate yield. And I just want to mention this recently published paper. It's a great paper. They were using our technology to allow the early prediction of embryo yield in DH protocols. And the big advantage is they were also showing that they could use the technology in the microspore culture. They basically diluting the microspore culture with our measurement buffer. And then they could measure and see and basically predict the embryo yields. It's a really good paper. I can recommend it to you if you're interested in. You will find the link below. Now we are getting to the end of the session here, and I want to conclude the main points. So we can say that we have no other tool available that is fast, standardized, and reliable in terms of pollen analysis for pollen viability, pollen lifetime, and the pollen amount. And also you can quantify the microspore stage. And in general, our Amphasys 32, it gives you the chance to monitor the whole development from the DH protocol to line characterization to speed up your breeding process. And with this statement, I want to thank you very much for your attention, and I'm looking forward to answer your questions.
Thank you very much, Georg, for sharing all these practical insights from our field study. And looking back at it, I think we had quite a great time in the field, having the chance to leave the office and lab for once. I was also quite busy throughout this session, clustering many questions that came in, and therefore I would suggest starting right away. If we look at sample preparation, there was a lot of interest in this funnel method that you presented. And one of the questions was, when you use that funnel method, do you only collect the pollen or also anthers falling into the Eppendorf tube placed under the funnel?
So basically we attached the funnel to a filter. So basically the filter prevented the falling of anthers in the Eppendorf tube. So basically in the end, we just collect the pure pollen for measurement. So you don't have to filter it later on. So you can basically go right and measure it. Yeah.
Mm-hmm. And another question, whether you could again quickly explain the pros and cons of the anther picking versus this funnel method.
Yeah, I roughly talked about that. It's if you have the anther picking method, you don't have really to harvest the plant. If you want to use the plant later on for seed, or you are interested in the seed, then you can perform the anther picking. If you can harvest it, then it's better, or we recommend to harvest it and use the funnel method, because you get an average across the spike. And it's also really dependent with the anther picking method, who is picking the anther and to know which anther is really developed. We experienced with the funnel method, if you cut the spike and the anthers are not mature, then they will not extrude. Basically, they will prevent that you will collecting pollen or cells from an earlier developmental stage.
Mm-hmm. I find that a very important point, that this funnel method seems to be selective for the very right developmental stage. And on top of that, I think what we observed is that there's quite some variation also between anthers or different spikelets. And if you use that funnel method, and you have a lot of material available, you can pool spikes. You can cut several spikes and basically average out this variation between single spikelets. But that's, I think, a very nice aspect of using this method. We had quite a bunch of questions related to pollen quantification. In your talk, you showed backed spikes in the field and also indoor. And which setup would you recommend?
If you want to work with paper bags, then I would highly recommend to do it inside, or I think in general it depends on the location where you are. If you don't have any problems with condensation issues during the night, so high humidity in the night or rainfall, then you can of course do it also outside. But if you have these problems, then you should go inside. We also recently come to a company that are offering plastic bags to use these, and this should avoid this condensation. We will definitely test this next year in our experiments outside, and to check if we can avoid these condensation issues. And maybe it can be also protected from rainfall. So if you want to go with the paper bags, then I would highly recommend to go indoor if you are in high areas where you have high humidity. Otherwise, you can also do it outside. Yeah.
Then we had another question related to the counting buffer that was used. Is that AF6 buffer or is that another liquid?
We developed a special for the counting a new buffer. So basically it keeps the pollen intact over a longer period of time and also in the field. As you can see, or as you could see, also it keeps it stable if you have rainfall. So basically it's a new developed buffer and you can order it soon.
Mm-hmm. We addressed with this development of this buffer the bursting issue of cells. So we work at a different osmolarity, and we also prevent sedimentation of the particles They were kind of the main goals in the development of this buffer. And maybe I just take over a question related to that, how often we actually replaced the liquid pollen traps. So liquid pollen traps were used on the one hand in wheat, but the bigger study on those pollen traps with this new design, with this cup, with the lid and the mesh, was done in corn. And in corn, we performed 2 experiments. In one experiment, we tried to get kind of a pollen shedding curve over the whole flowering period. And the other one was kind of an endpoint determination. So after the flowering period was over, we collected the traps. And in the second case, the traps were in the field for a little more than, I think, 2 weeks. And we didn't observe any fungal growth. That was one of the questions, whether we observed fungal growth in these traps. Because on the one hand, we prevent bigger particles from flying into the trap. So an insect that could carry a fungus or wouldn't kind of release it in the buffer. Of course, fungus is also flying in the air, but we kind of prevent fungal growth by not providing any substrate for the fungus for growing. So these buffers don't contain any sugar. So this has not really been an issue. Then we also had this other pollen trap design with the paper funnels. And there came a question what kind of paper we used for these funnels.
Yeah, we just used ordinary printing paper that you're using for your printer. So you can basically just wrap it around, make a funnel out of that, glue it together, or just make it together so that's holding, and then you're ready to go. And that was not a specific paper that we were using.
Mm-hmm. Another question on whether we can share the design of the pollen traps.
Yeah, of course, that's not a big deal. You can drop us an email and we can share the knowledge, and we can also share you where we get it and how to prepare it, and then you can also order the counting buffer at the same time.
Yeah, of course. Another interesting question on the throughput of the technology. How many samples did we measure per day?
Yeah, we measured quite a lot. So basically, what you can measure up to 200 samples or even more. It depends on how fast you are with the sample preparation. I think in our case, we were a little bit lower. We were not that fast, 200 measurements. But I think we came to the 100 measurements very close that we performed in the field per day.
Mm-hmm. Then related to sample preparation, how much pollen do I need for a measurement?
So if you're focusing on anther picking, or this is your favorite method, then we experienced that 6 anthers, they are enough, and they can deliver enough pollen for the analysis. If you're using the funnel method, then even 1 spike can be enough. But if you're more interested to get an average across your field, you can also use more in the funnel method. So we normally used 5 spikes for the funnel method, and then you get a lot of pollen that you can perform the analysis, and you're really on the safe side.
Mm-hmm. Thank you. And then another question, whether those findings and developments are also applicable to other crops, not just wheat,
so
barley and rye.
So that's an important point. So basically the anther picking, that's not a big deal. So the anthers are also existing in barley and rye. So basically we can use that. This funnel collection method, we tested in wheat. So basically it has to be tested in barley and rye. So if the anthers are extruding by the cutting, then it's not a big deal. It can be also measured. And also the chips that we are using, it's the same. So basically, the method is really applicable to these crops.
Then we had two questions on this Pollen Lifetime experiment. And one participant asked what the conditions were in this experiment.
The conditions were at room temperature, or basically outside. It's really important to do it outside and at room temperature or at 25 degrees, because normally in the field, if you want to collect the samples in the field, it should have representative conditions. So it does not make sense to chill it and do the lifetime, and in the field you have higher temperatures. I also showed that results that if you chill it, then you can maybe delay it a little bit, or you can delay the pollen viability loss. And yeah, so basically the conditions were at field conditions.
And the pollen was stored or preserved dry and not in the buffer, right? That's another.
Yeah, that's also important. Thank you. Yeah.
Then, now we talked a lot about wheat. There came a question whether it's also possible to measure other small grain cereals with the same setup, with the same chip.
Yeah, I roughly talked about that. So basically, the chip is the same. So you can use an E-chip. You can also use the buffer that we were using. So the setup is quite the same. So if you are interested in measuring another species, then just contact us. We also are happy to help you with that. So the method is also applicable to other cereals.
And how about microspores? Is it the same setup that is used, or does it differ?
For microspores, you have to use the D chip, not the E chip, because they are smaller. And you have to use the anther-picking method, of course, because they will not extrude the filaments. And you have to squeeze them because normally they will not get out of the anthers. And then you can use AF6 buffer and you can run your analysis. So that's also quite a straightforward procedure.
Okay, thank you. And another question, whether we can measure more than 10,000 cells in a measurement.
Yeah, of course, that's possible. That's not a big deal for us. It will increase the duration of the measurement. And in the end, it's also dependent on how much cells do you have actually in the buffer. Otherwise, you will run out of sample. But it's also it's possible, but we recommend 10,000 samples because you will get a robust, statistically robust result out of them. Measuring more does not increase the accuracy way further, and it does not really benefit. It just takes longer. The measurement takes longer. Okay, and another question on where we actually did our measurements. So we did kind of a field trial, but this person is interested where we placed our instrument and setup. We directly put it on the field. So here in Switzerland, it was a trial where different varieties were shown, so we could easily get access to them. And yeah, basically our setup was in the field, so we could measure there. We had the battery packs that are needed with us to power the instrument and the notebooks. But yeah, it's working. It was working, and it did a good job there.
And another question that was actually asked twice in the data set that we showed about the results of bagged spikes, whether we corrected the pollen amount per spike for the number of florets per spike.
I think we didn't know, we did not. We collected the whole pollen that is shed from the spike. So basically we just collect that. Maybe it's a good approach, and then we could check the variation. Yeah. Mm-hmm. Maybe for the future we should try that.
Yeah, I think it's a great input, and I think it also explains the variation we observed. If you remember those box plots,
you're right.
Kind of some variation between within one variety, and I think that could be actually the reason for that.
Yeah,
yeah, it's a nice hint. Welcome back.
Thank you very much, Silvan and Georg. Very interesting. Very many questions. Still coming in, as I see. Unfortunately, there is no time to go into more details to answer all of your questions. If you have more questions, I see they are really specific. Please contact us, get in touch. We can give you all the details. We can help you, consult you when you would like to do the same experiments. Get in touch, write us an email, info@amphasys.com, or you'll find the details on our website. Those of you who already know our technology and support team might contact them directly for more details. They're very happy to share their experience. Thank you everyone for attending this session. I hope you benefited a lot from it. Thank you, Georg and Silvan, for going into all those details. This was our last session of today, but not the last session of the virtual Amphacademy. There is more to come. Tomorrow there will be a session on corn pollen analysis. So actually similar to what we did with wheat, we did a field trial on corn. So all of you that are interested in learning more about that, you can still register and join us for this session. And then there will be two sessions specifically for Amphasys 32 users, helping you speed up your pollen analysis workflow and getting the most out of your data analysis. So if you haven't subscribed yet, check it out and do so. Thank you very much for being part of this today. As you go out, there is a short questionnaire. I would be really happy if you could let us know your feedback and help us improve such sessions in the future. Thank you very much. Have a nice rest of the day and hopefully see you tomorrow. Bye.
Thank you. Bye.